Hello YouTubers! In this video we're going to be going through LeetCode problem 111, which is minimum depth of binary tree. So if we look at the problem, it says given a binary tree, find its minimum depth. The minimum depth is the number of nodes along the shortest path from the root node down to the nearest leaf node. Note, a leaf is a node with no children. We'll learn some new terminology today. So the input here that we're given is this binary tree, which is the 3, 9, 20. Then the null is for the 9 because it doesn't have any leaf nodes off of it. And then 15 and 7. So the output is 2, just the 3 and the 9. For the second example, this one's a little hard to visualize because they don't give us a picture. But basically, we have a root node of 2. We don't have anything on the left branch, and then we have a right branch of 3. The 3 doesn't have a left branch. It has a right branch of 4, and so on and so forth. So it's basically just a binary tree with a right branch and nothing on the left. And so the output is just going to be 5 for the 5 nodes on the right branch. Alright, so let's see how to tackle this. So LeetCode gives us this method. It's expecting an int value for the minimum number of nodes on the branch, on the binary tree. Then we pass in a tree node of root. So if the root is null, we're just going to return 0. Just get rid of it. If root left is null and root right is null, we're just going to return 1. Return 1 for the root branch. Now we need to assign the minimum depth to the integer max value. So this is what we'll return. This is minimum depth. We'll be adding to that. But to make sure we get the minimum depth, we assign this to the max value, which is a huge number. Alright, if the root dot left is not equal to null, then we're going to assign the minimum depth equal to math min, which basically takes the min of 2 numbers. So then we're going to call min depth again. You guessed it, a recursion. And we're going to pass in the root left. And then the minimum depth, which will, for the first pass, will be the max value. So basically, it'll determine which of these two is smaller. We'll do the same thing with the right branch. Math min of root dot right, and compare that to the minimum depth. So you'll notice minimum depth gets assigned up here. So when we get down here, the minimum depth is going to be whatever the result of the root dot left was. And then we're going to return minimum depth plus 1 for the node that we're currently on. We always have 1. And that is pretty much it. So let's run this through the debugger here. And I got my handy dandy visual aid here. So we're going to use the example 1 in LeetCode. And so I built a binary tree that looks just like this. So the first thing we're going to do is go into the method. Alright. Okay, min depth. So we're dealing with the 3 now. If root equals null, which it isn't. If root left is null, which it isn't. And the root right is not null either. So we're going to assign min depth equals the integer max value, which is 2,147,000,000, yada yada. Huge number. Okay, if root left is not equal to null, which is true, we're going to assign the min depth equal to the minimum of the root left or the 2 billion number. Okay, so now we called min depth down here, so we're dealing with the 9. So we go through here, its left and right are both null. So we're just going to return 1. So now we're back to the 3. It remembers where it left off. So now we're going to deal with, this just goes into the method, the math.java, that actually determines the minimum amount. Okay, so we get a minimum depth of 1, which was passed back from the 9 on the left branch. So now we're going to go into the right branch because it is not null. So root right, you go up here. Now we're dealing with the 20, value 20. And the 20 also has a left and right branch, so we're going to have to loop through those as well. So because we're on the right branch now, we're going to go back and assign the minimum depth equal to this massive number. And then we're going to go into min depth again with the left node. The root is not null, but the root left and root right are null because the 15 doesn't have a left or a right branch. So that returns 1. So now we're back to the 20. And into that math.java, it returns 1 for the 15. And we're going to do the same thing with the right node because we have the 7. So we have the 7 here, we're dealing with that now. And the root left and right of the 7 is null. So we're just going to pass back 1. Okay, so now return min depth 1 plus 1. Okay, so now it's going to return, now we're back, it returns 2. So now we're back to the 3. We've done the left, we've done the right. So now min depth is still 1. And we just add 1 to the min depth to get for the value of 3 and pass that back. And so the result is 2 for the 3 and the 9. Alright, let's run this through LeetCode. See what we get. Accepted. Now we'll submit it. Faster than 76. Should I try it again? Why not? Oh, same number. Alright. Finally, I like to go through the space and time complexity. Time complexity is the time it takes to run a problem, and this is O of n. N is the number of nodes. We have to visit each node once, and so as you increase the size of the binary tree, it's going to take longer. And space complexity is also O of n. Worst case scenario, we need space for each calculated node. So that is also O of n. And that is it. As always, good luck in your interviews. Thank you for watching, and we'll see you next time.